Hi, this is me, Geek, and I'm Dan, and you're on my robot cameraman right now. At least something like version 3 or 4 of the robot cameraman. I've started this video a few times and I'm never quite sure how to present it, mostly because I don't really know what each step is going to be. Like, I've tried a few things that didn't work. So I decided what I would show is where I am right now, which is far from complete, and just sort of talk through the components and how everything's working together, and then we'll talk about some of the stuff that I've got planned to take it to the next level, and that will probably end up being a future video. So this is Robot Cameraman Part 1. Let's take a look. Actually, before I take it off, I'll use my phone camera just to sort of show the camera, the DSLR in situ. So we see it on its main gimbal structure here, and I'm driving the zoom with a belt looped around the zoom thing. So this is actually pretty good. It just needs to be reasonably tense, and it can just rotate this back and forth to manually operate the zoom. That works great. I did have a version on the gimbal previously where I also, on this side, mounted another motor to drive the focus ring, and you'll see I have these blue tape things. It turns out that the focus mechanism, the way that works, is relative to the speed of the turn, and I just had an absolute nightmare getting any consistency out of it. So now I'm just relying on the autofocus to do its job, which mostly seems fine. The camera is secured in place on this cradle with a little block that I've unscrewed now, but this obviously tightens down to lock it in, and then this just slides out the back. So let's take the camera out. So the gimbal mechanism has actually been the feature of previous videos. I previously had this whole structure just mounted on top of my tool cart, and it on its own has allowed me to get some really cool shots that I've been very happy with, like this one. And so yeah, this on its own turns and pivots and zooms. So the turning and the pivoting, this whole structure, I got this from Thingiverse. I think, is it Fawnbull, the maker of that? So that was just literally download it, print it, follow the instructions for at least the mechanical parts. The zoom attachment is my own addition. And actually, this is currently broken. I probably need to reprint that, but for now it's bolted in place. So that on its own is a great thing, but it's a little bit limited. It's obviously always from a fixed point, so you can kind of zoom and pan around and get different shots, but I really wanted to be able to do stuff like change height and do more tracking shots. So that's where this structure comes in. Now, originally, I actually made this using these aluminium channel pieces that I had a bunch of, which was nice and lightweight, and it was kind of strong enough doing this, but it was just a little bit rickety this way. So I've ended up replacing it with a steel structure. This piece of wood I just have in here to stop it moving, because without the camera on this end, the weights are too much and I couldn't be bothered to faff with it. So this just stops it moving for the moment. So pretty standard kind of setup, I guess. We have basically two, let's try and get over here. So if we look at it like this, we have two U-shaped structures. This central one kind of this way up with a central pivot pin down at the bottom, and then at the end, same thing but the other way up. And these have a set of holes drilled in the sides for the pins here to go in. Again, originally I used, I think, M8 bolts, which wasn't really strong enough, and then I made a bunch out of this 8mm steel precision rod. So in fact, you can kind of just about see maybe the back end of a rod that was welded in there. So originally, again, I had the pins, I say originally, in the version 2 or 3, I had the pins basically welded through and all the way through both sides of the leg in all 4 points. So you'll notice I only have 2 struts on this side and 1 strut on that side. There was one down here, and there was another U-shaped structure here in version 2, but when I got it all connected, it was just way too stiff. It just was not free enough to move, and I think a lot of that is just error from welding, where things tweak slightly, and like drilling is not perfect. The sum of all that error basically made the whole thing way too stiff to move. Specifically, this central 3D printed cog with a motor mounted down here obviously needs to be able to drive it up and down, and it just was never going to work. So I ended up cutting all of the pins back halfway so they only go through one wall of this tubing, and getting rid of that whole bottom leg down there. The combination of that made this much freer moving, which is good. So as you can see, the counterweights at the moment are just some free weights that I'm just holding on here. I should probably put something to more securely clamp these in, but for the kind of speed of motions, that's not too bad. And down at the bottom you can see, if I can get that to focus in there, we have a 16mm steel bar that is currently clamped in my big workbench vise, and a round plate here which is welded on, so that whole thing moves. And you can just about see I do have some drilled and tapped holes in that plate, which hopefully in the next kind of version is going to be where I will mount another motor to hold, and the idea is there'll be another one of these kind of herringbone cog kind of things under here, and that will allow me to control the entire rotation of this structure in addition. So that's sort of the mechanical side of where we're at. So let's talk about the electronics and then the control. Right now I have all of the electronics mounted under here. This was probably a terrible idea, but when I had the gimbal set up previously, this was all wired up to be close to it, and it just seemed the easiest thing to do was just to hang all of this stuff underneath. It does add more weight here, which just needs to be counterbalanced. I do now have some plug adapters, these things, that basically connect together like that. So what I'll probably end up doing is wiring all the motors into these and then run more longer cables so all the main electronics is off the body and we just plug in those. But yeah, for now we have X, Z and Y labeled just so I'd remember which ones were which. These are obviously the stepper controllers, and then tucked back here is the Arduino. The Arduino is running a Gimbal controller. I used that a bunch for CNC stuff in the past, so I was pretty familiar with it. And then obviously this is just sending all of the step pulse signals, and then the only thing sort of coming back off at the moment is the USB to the Arduino and the power input. So if we trace those cables back, the power right now is a PC CPU or PSU controller with a basic breakout board that lets you get at the various voltages it supplies, and we are tapped into -12 and +12 to give us a 24-volt supply. If we come back over here, we'll see there's actually a second Arduino and another controller. So CNC and Gimbal in particular can control 3 axes, which, count them, 1 rotation, 1 pivot, 1 zoom. So that's all that this one can manage to control. So there's a second Arduino controlling this controller, which links up to this guy here, who is mounted on a set of brackets to keep him as secure as possible driving the central wheel. Now, of course, all of that is all very well for electronics. and mechanical, but all of that needs controlling, and that's where the brains of the operation comes in, which is this little guy. He is a Raspberry Pi with a screen attached, running a piece of custom software that I wrote. So it's currently pretty ugly. Let's get a better view of that and we'll talk it through. So what we can see on the screen at the moment is that I have a simple toggle for whether I'm controlling the crane or the gimbal. I have the ability to set what the current feed rate should be to some standard options over here, or I have a text intro box to make that custom. And over here we have a bunch of information that is poorly overwritten and not making best use of the space. If I bring that over, maybe I can get a bit better. But this tells me what the current position of the gimbal is, the crane position. Actually, no, I'm not writing the crane position out yet. And the speeds that are associated. And then I have these save positions, Y, B, A, X. So that is the real key to all of this, is that basically all of that is controlled with a standard controller. So when I'm in gimbal mode, this guy controls X and Y, rotation and tilt, and I actually have this doing small movements and this doing large movements. So I just set what I think that should be for the axis, and then I have on the crosshairs controlling the zoom. So you can manually jog each axis the way you want it, and then the Y buttons, Y, B, A, X, you press those to save that location, and then the buttons on the back map to those. So if we go back to here, Y maps to left back, B is right back, A is R1, X is L1. And so by doing that, I can move to and save 4 different positions for the gimbal and the crane, save them, and then just recall them with this. That's pretty handy and actually gets me a hell of a long way. You'll notice there's also add waypoint, delete waypoint, and I have a couple listed. So it's actually, I also have the ability to, for each given current location, I can set a waypoint and how long I want to wait at that waypoint, and just add the current location. So I can again jog around, move, and build up a list. And then when I hit the start button on the controller, it will move to the first location, wait for the amount of dwell time, move to the next, move to the next. And that's quite nice for being able to set up routines, particularly if I'm doing kind of longer work somewhere and I just want it to rotate between a bunch of different positions. That can be quite helpful. So what's next? Well, as I mentioned, the key thing is going to be rotation of the main crane arm. So that means new motor, new cog. I need to create a proper base for this. I obviously don't want to consume my vise forever, and ultimately I want to be able to move the whole thing anywhere I like around the workshop. So I need some kind of sturdy-ish base that I can just deposit on the floor close to where I'm going to work, set everything up. That also means probably moving all of the electronics, controllers, Raspberry Pi, etc. into that base unit so the whole thing moves. I'll probably get a dedicated power supply. Using the kind of lab supply is fine for now, but as I make this more robust, we'll go with a proper supply. What else is there? Rotation axis, floor. Oh, and I need to rewrite the software. Currently it's pretty hackily put together. I'm not the best programmer in the world. I need to obviously support control of the rotation axis. I want to add a bunch of new fine controls. At the moment, the only thing I have is feed. So you may have noticed in that intro move, the axes don't necessarily arrive at the same point together. And that's kind of a problem, but there is a piece of G-code I found where instead of telling it how fast to move, you can tell it how long you want the move to take. And I'm really hoping that I can use that to basically just give both the gimbal and the crane the same time to use. And so whatever kind of positions they're at, they'll interpolate smoothly to arrive together at the same time. We'll see. But there's going to be probably a lot of refinement of the software to try and help me achieve the specific kind of camera moves that I want to achieve. Also, I mean, I used green because active, but you know, brand colors need to come in. Anyway, that's a quick overview for right now of where I am with Robot Cameraman project. This was part 1. In part 2, hopefully, we'll start to see some even more cool camera moves. Thanks for watching. See you next time.